Hello everyone, welcome back to Bytes of CC. So in this episode, I'll take a SQL query, and while finding a solution to the query, I'll walk you through almost all the important SQL theories and syntaxes that are like a must know for a CSE student. So I saw this question on lead code and immediately it crossed my mind that why don't I use this particular question to explain concepts, and that way it will be less boring. So there are two tables here. One is the employee table where there is an ID, which is the primary key, which uniquely identifies the employee, of course, the name of the employee, and the salary, and the department ID. And there's a department table which has the primary key as ID, which is the department ID, and the name. And this particular field, department ID, is the foreign key that references this table from employee to department. And what are we trying to find out? So it is given that a company's executives are interested in seeing who earns the most money in each of the company's departments. A high earner in a department is an employee who has a salary in top 3 unique salaries for the department. So write a solution to find the employees who are high earners in each of the departments, and you can return the result table in any order. They have also given a sample employee table and a sample department table. So there are two departments, IT and sales, and there are employees for both the departments given here. And this is how the output is supposed to look like. And the explanation, in the explanation, it says that in the IT department, Max earns the highest unique salary. Both Randy and Joe earn the second highest unique salary. This is Randy and Joe. And Will earns the third highest unique salary. In the sales department, Henry earns the highest salary, Sam earns the second highest salary, and there is no third highest salary as there are only 2 employees. So we will build the solution part by part to this problem. Like the initial one will be a very specific rudimentary one. Next, we will solve using nested SQL syntax, and the last solution will be without any nested subquery. And now this question can be tackled very easily using Windows function like dense rank. But neither the compiler of LeetCode allowed that, nor I will use it either, because it is not our purpose. Now, since the title of the video says that this is going to be a revision video, so I assume that you know the very basics, like what it means if I say that select star from table X, or if I say select column 1, column 5 from table Y, and so on. Just the very basics. So let's get started with this. First, we will see what the top 3 salaries are. So in order to do that, we will need to sort the salaries in descending order, and then we will fetch the top 3 values using the keyword top. Let's do it. This is how the syntax or the query is going to look like. Select top 3 salary from employee, order by salary descending. So this order by salary descending, this asks to sort the salary, and descending order means we sort the salary from highest to lowest. Now this is what it returns. But wait, this is not we are looking for, right? The value 85,000 is returned twice. But why? See, if you run this query without using this keyword top 3, this is what you get. So the entire salary table gets sorted from descending, from the highest to the lowest value. For now, we are not considering the department ID. We are just keeping it on hold for some time. Okay. So now when you are using this top 3 keyword, it simply selects the top 3 rows. So this top keyword is definitely not any intelligent keyword which can understand that by top you mean the top 3 unique values. So in order to do that, we will need to use another keyword which will return only distinct salary. And that is a distinct keyword. So now your query looks like select distinct top 3 salary from employee, order by salary descending. So whenever you are to use both distinct and top together, what we will do is we will first write distinct and then we'll write top. And then it returns these values. So this time it's fine, but we are still missing out on something. We have to find the top 3 salaries department wise. Now remember, whenever we need to group all rows with the same column value, we use a keyword like group by. So let's try using group by here. Let's use that. Select distinct top 3 salary from employee, group by department ID, order by salary descending. And what do we get? We get this. This is totally wrong. But why? The reason is group by returns one row per value of the column. So it works for queries with some aggregate functions like max, average, count, and it tackles questions like what is the max salary in each department or how many employees work in each department. So here you will be using this max keyword, and for here you will be needing to use this count keyword. The general syntax is like select aggregate function, column name from table name, group by column name 2. So we'll come to that later in this particular video. So for now, we cannot use group by here for now. So let us build a more crude solution. So here we will select the top 3 salaries from the department separately by plugging in the department ID, like hard coding the department ID using the where clause. So in order to do that, the query now looks like select distinct top 3 salary from employee where department ID equals to 1, order by salary descending. And it returns the top 3 salaries of the the IT department. And again for department ID 2, I rerun the query, select distinct top 3 salary from employee where department ID equals to 2, order by salary descending. So always try to remember we first use select, then where, and order by comes last. And this is what we get. So now we are to fetch the intended column that match these results. So these are the set of values, and the salary we need to return the names, departments of those employees which will match, like whose salary will match any of these values for IT department and any of these 2 values for the, I think, sales department. That is the department ID 2. I don't remember the department right now. So when you do that, when you are comparing to a set of values, you will use the keyword in. So if you use a query like select star from employee where department ID equals to 1, and so you are actually plugging in that in clause with where, like where department ID is 1 and the salary in select distinct top 3 salary from employee where department ID equals to 1, order by salary descending. So this returns those 3 or 2 values, and this is the outer query where the salary value is to match the salaries returned by this query, this nested query, and this is what you get. And since you say select star, all the columns will be selected like this. Now this is a numeric set, right? This is a salary which is an int, the, what shall I say, the data type is int. So this is a numeric set, so we can use operators like greater than, less than, equals to, etc. here to fetch results. So the plan is, see, when we execute this query, we get a set of results. Here we are fetching the top 3 salaries from department IDs 1 and 2. So in order to use these operators, you can compare these operators to only one value and not a set of values. So what to do in this case? We need to return just one value, so we will actually return the rows where the salary of the employee is at least as high as this salary. That is, in other words, the salary of the employee is greater than, equals to the third highest salary. Now the third highest salary, in this case the second highest of course, the third highest salary, say for in this set, is the minimum salary of the set returned. So if we take a minimum of this returned values, we are to get the third highest salary, and that is done using the minimum keyword. So the query looks like this: select mean salary from, this is the old query which is getting repeated for now, select distinct top 3 salary from employee where department ID equals to 1, order by salary descending as T. Now why this T? T used here stands for a temporary variable. Like, since we are to select minimum value of a column that belongs to a table, now this particular table is not present in the database or the schema. So we are holding the values returned in some temporary variable T. This T stands for a temporary table. So we are holding these values in a temporary table T, and from this T we are fetching the minimum salary. So this gives the value 70,000. So we are missing out on so many things. We are to return an output that contains the name of the department that comes from department table. Okay. So this employee table has ID, but the name is from the department table. So in order to get the results, we now need to join the two tables in the manner where the department ID of the employee will match the ID of the department table. This is done using inner join, where we join two tables on a matching column common to both tables. Now, in inner join, suppose some values of the matching column is present in one table but not on the other table, then the rows that contains those values will be discarded in the result table. So it will only like this acts as a set intersection. Only the matching values will be returned. If it contains some discrete values and some discrete values of these tables, like these values will be discarded in the returned, like the returned table or whatever you call it. So it is more like a set intersect operation. So I'll come to the syntax of the inner join in a while. And this is what the joining will actually look like. I'll come to the syntax later. Before that, there is also another thing which is to be considered, that see what was name in the department table is returned as department in this table. What was like name in the employee table, that was returned as employee in this result table, and salary is salary. So this, when we are trying to fetch the rows, the column also has to be renamed, and that renaming is done using the as keyword. Now combining both inner join and as, this is what is to be done. Like select department.name as department, employee.name as employee, employee.salary as salary, from employee. Okay, I'm stopping right now because why am I using department.name or employee.name here? See, in this join column, there is one name here and another name here. So this stands for the employee and this stands for the department. So if you just write name, the query will get confused. It doesn't know which name to return. So in order to separate, or in order for the query to, or the compiler to understand, we have to use the table identifier, which is used. We'll write the table name first, then we write a dot, then we write name, which means that the first name to be returned is the name from the department table, and the second name to be returned is from the employee table. And this as keyword is used for renaming. So department.name as department, employee.name as employee, employee.salary, well, if you had written salary, it wouldn't have been a problem, but this would have thrown an error. Okay, coming back to the query. So from employee, inner join department on, so this is where we will be mentioning about the common columns. So on employee.department equals to department.id, and we put the where clause here since we have to find it out separately, where employee.department equals to 1 and employee.salary, so we are using greater than equals to the third highest salary. So this is how the third highest salary was returned, or the minimum of the set was returned. So employee.salary greater than equals to select mean salary from, select distinct top 3 salary from employee where department ID equals to 1, order by salary descending as T. So when we run this, this is what we get as the output. Similarly, when we replace this where employee to this has to be employee, sorry, I think it just, when I was typing there was some mistake, I think. Anyways, this is where employee.departmentId, I just missed this somehow. Anyways, if I replace this with 2 and also replace this with 2 here, I get for the sales department, employee and salary. So we are getting 2 subsets. Now if by some means we can place one over the other, like if we can vertically join the results, we will get the intended output, right? A very rudimentary one, but we will get the output according to whatever was given in the snapshot or in the example table. So how do we do that? This is done by using the keyword union. So we get two things. One is a join and the other is a union. Now join joins the table side by side or horizontally, and union joins two results one below the other. That is, vertically it joins the results. There is also another constraint in union, that is, the columns must be same, otherwise it would not make any sense, right? So for inner join, only one matching column was needed. But in case of union, all the columns must match. So when we are using this union, so how do we use this union? So we will write this query once for department ID 1. Then we will use this union, which actually works like a glue here. And we will repeat the same query with department ID 2. So it looks like this. Select department name, dot name as a department, employee.name as employee.salary as salary, from employee inner join department on employee.departmentId equals to department.id, where employee.departmentId equals to 1, employee.salary greater than equals to select mean salary from select distinct employee.salary as salary from employee, where employee.departmentId equals to 1, order by salary descending. Limit 3. Now, why did I use limit 3? Because I was using MySQL, so top was actually not working there. It was having some problems, so I had to use limit. So top and limit basically works almost in the same manner. But if you're just writing like that, you actually don't really need to use limit 3. You can of course use top 3. It works the same. And I used union and I repeated the same thing here, and this is what I got. So this is a workable thing, but a very wrong solution to the problem. So why is it wrong? Because it will work only for the table where there are departments with IDs 1 and 2. If more departments are added to these tables, the query will fail, right? Because it is very specific. We are just hard coding the department IDs over here. Department ID equals to 1, department ID equals to 2. So what to do now? If we try to build a better solution, we will need to stop hard coding the department ID value. So if by some means we can hold the value of the department ID for each row, and then in the subquery we plug in that value to select the top 3, we can just plug in the value to select the top 3 rows. So to make things clearer, let us look at what I mean. Now this is how your query looks like. Select d.name as department, e.name as employee, e.salary as salary from employee E, inner join department D on e.departmentId equals to d.departmentId. Okay, one more thing which I need to mention here. This is known as aliasing. So instead of writing the whole employee, like typing out this employee, if I just write, when I write E just after this employee, it sends a signal to the compiler which says that from now on E will mean employee. For this particular query, of course. Not that for the other query it will work. So for now, for this particular query, E stands for employee and D stands for department. So first of all, it helps you from it just you don't have to type out long names for tables like employee and department, and it will also help you in one another case which will come to very shortly. So for now on, for now, just let us concentrate on this particular query. So where e.salary greater than equals to select mean salary from, this is the same thing repeated, select distinct top 3 salary from employee, where department ID equals to d.id, order by salary descending as T. So in this nested query, the employee table, now this employee table is unrelated to the outer employee table. This employee table and this employee table, this is actually not related. So each time for a particular department ID held by the row, this subquery is executing to find out the salary cutoff for this department ID and will return the row if the cutoff is satisfied. That is the salary of this particular individual, that is e.name has a salary greater than equals to this salary value returned by this particular subquery. So this is what is done by, so department ID equals to d.id, and this is what you get as the output. So this is a much cleaner kind of thing, right? You don't have to write this union and so many other things here. So now if you ask me that if I write that where department ID equals to e.department ID, will that work? Like if you like to write something like this, department ID equals to e.department ID, will it work? Yes, of course, this will work too. Now, let us start trimming off the excess. Now, you can get the exact same result if you do not mention the term inner join. And just by using the where clause, if you write your query like this, select d.name as department, e.name as employee, e.salary as salary from employee E, department D. So we have just gotten rid of this line, okay? Where e.departmentId equals to d.departmentId and e.salary is greater than the whole thing here. I'm not repeating that. Then also you will get the exact same result. Now let us get rid of this particular nested subquery. In order to get rid of this nested subquery, we will finally move on to the last concept that is left to be understood, and this is known as the self-join. So what self-join does is, a table joins with itself on some column, and it is in this self-join where the aliasing or that table renaming also plays a very important part. So how will that be solved with using self-join? Now this is what your query is going to look like, and in fact this is the final query. So what does it say? Select d.name as department, e.name as employee, e.salary as salary from department D, employee E, and again you bring again you do a self join with employee, and now you use the alias as E2, employee E2, where d.id equals to e.departmentId, and you join employee E and E2 on department ID. So you're basically, this is your E, this is your D, and this is your E2, and E joins E2 on department, and E also joins department on department ID. Okay. So the where doesn't stop here. So and e.salary less than equals to e2.salary group by, so group by comes here again, d.id e.name having count distinct e2.salary less than equals to 3 order by e.salary descending. So that is quite a mouthful. So what is it actually doing? So of course it gives you the correct output, and so we are taking group by on department ID and employee name together of the E table. And what it does is it provides that necessary precision to analyze salary relationship at individual employee level within each department. And using this group by, like having count this, order by this actually chooses the top 3 salaries. Now this is still not clear to us, right? What is it doing? Let's decode the query itself. So when you are joining these 3 tables, so let's just forget about this part. Let us just concentrate on up to this line 4. So you join the 3 tables, and this is a snapshot of this joining. The whole table will be much larger than this. This is just a snapshot. That is in fact what was written by the compiler. So what happens here is, see, I can actually, I'll just select the sales table. That way it will be easier for me to explain. So I'm just considering these 4 rows here. So it says that e.salary has to be less than e2.salary. So this is your E and this is your E2. So what is this e.salary less than equals to e2.salary doing here? So suppose, so let's come to this particular row. So here we have Sam. Sam is the e.salary for Sam is 60,000, and this is getting compared to e2.salary. So it is getting compared to Henry, who earns 80,000. So is e.salary less than equals to e2.salary? Yes. So this gets the value 1. Again, when you consider this row, again we are we are doing a group by on department and sales together. So just forget about this. So sales and Sam is one group, and since this was true, this got the value of 1. Coming to this particular row, where again we have sales and Sam, that is the same group repeating. And now e.salary is 60,000 and e2.salary here is again 60,000. So is 60,000 less than equals to 60,000? The answer is yes. So the total value for the group sales and Sam now is 2. Now what does this 2 actually stand for? So 2 actually stands for the rank. Like if there are other people working in the same department, what might be the rank, or like how many people actually earn greater than equals to Sam? This is what it means. Like if I do away with this, If you consider this particular query, where we are, like, apart from department, employee and salary, we are also returning this count distinct e2.salary as CT from the entire thing. We have done away with the having clause. This is what your entire table is going to look like. See, Max earns the maximum salary. So the count for Max is 1. There's only one person who earns greater than or equals to Max. And for Joe and Randy, this count would have been the value of 3, because there are technically 3 people earning more than. So Joe earns more than equals to Max, Joe and Randy. But this is where we are using this distinct keyword just to do away with repeating values. So that is the reason why Joe and Randy gets the value 2. Henry in the sales department, he earns the highest, he gets the value 1. In case of IT, Will gets the value of 3, since he earns 70,000. Janet have 4 people earning greater than or equal to her, and then Sam has 2 people earning greater than equal to him. And this is why we are actually finding out the top 3 salary earners, and this is why we are actually introducing this clause having. So in group Y, you can't use where clause here. Where clause is here. With group Y, when you are trying to select some particular values, you will be using this keyword having. So group by something, having count distinct e2.salary less than equals to 3, and order by salary and descending. So when you are using group by, having and order by, this is exactly the way how you will be using that. First comes group by, then you will have to use having, and order by is to be used at the last. So this is your final answer to the question. Select d.name as department, e.name as employee, e.salary as salary from department D, employee E, employee E2, where d.id equals to e.departmentId and e.departmentId equals to e2.departmentId. And this is very important, because if you don't use this e.salary less than equals to e2.salary, all the count values will be 4. So e.salary less than equals to e2.salary, then you group by d.id, e.name, having count distinct e2.salary less than equals to 3, order by e.salary descending. So this is what the final query is going to, answer to the query is going to look like. So that's all for today. So thank you for watching. I have also have a hands-on tutorial on SQL which was done much earlier. You can also go through it if you want to learn SQL from scratch. It also contains how to create a table, how to enter values to a particular table, delete values and so on. So that's a more detailed thing. So thank you for being patient and thank you for watching.